All right, let me just do this. Put the camera like that. Okay, we're good. It's amazing how blind I am. Blind as a bat. I'm blind. Okay, here we go. Now, we did in a video, I don't know if it was a video, but we did the 2 review, correct? We went through it and I answered questions, correct? Now, let me ask you, Sierra and Greta, are you with me? Let me ask you a question, and I want an honest answer, okay? Can you do that for me? Look at 2 right now. Take a few seconds to just go over 2. It's going to be due soon, right? And tell me if there's anything in that you have, it's this, correct?
Yeah.
Yes? Right? Is that it? Okay. Is there anything in that packet that you're a little bit confused about? Okay, you have mixtures. 2.1 is a review. It says review vocabulary, completion, true, false, mixtures, elements and compounds, chemical reactions. That's vocab, okay, matter and change, okay. Let's do this. Let's do one thing. I think I put it on another video, but there's one that's in your book about the organization of matter. Which page is that on? Here it is. Use my glasses. Okay. Here you have matter. Okay. Up here, you have matter. Okay. And in your book, it says substance. Okay, that's pure matter, correct? Pure matter. They use the word in your book, homogeneous. Do you understand what all that means? Like everyone's the same. Okay? You could say homogeneous relative to gender. What does that mean? Homogeneous gender. Only males, only females. Homogeneous nationality. What does that mean? You're all from the same country. You're all from South Korea. You're all from Canada, Egypt, the United States. Right? Yes? So homogeneous means everything's the same, correct? So what does that have to do with substance? It's a long word. Homogeneous. That means, like, for instance, it's all water. It's all the same substance. It's all water. It's not salt water. It's just pure water. It's a single compound. Or it's a single element. It's all gold. Wouldn't that be nice? It's all the same. And then on the other side, you have mixtures. Correct? For instance, they use the word heterogeneous. All mixed, boys and girls. Smart students and students who struggle. Correct? People from all over the world. Tell me where everybody's from. Give me a country that you recognize as your home, regardless of your birth. Just give me a country, quickly. Ethiopia. England. The UK, you mean, or England? Ooh, she's tough. England, I like that. She's an English girl.
United States.
US, the United States. The US. Australia. Canada. A lot of Canadians, huh? South Korea. Finland. USA. USA, America. South Korea. Canada, America. Who else? England, South Korea,
Here, UAE.
UAE. Where? UAE, right? Oh, Egypt.
Germany.
Germany,
Yes.
US, Australia, right? Okay. So all different countries. That's heterogeneous. But what I can do is I can separate into substances. I can separate a mixture into substances. So I can say I have sand and salt. How would I separate sand and salt? Sand is, yes,
You put them in a cup, put water in it.
yeah. Put them in a cup, add water, and filter, right? And then dry, what's the filtrate? The stuff that comes through, right? The salt water, right? Then you let the water evaporate, and you get your salt, and then you have your sand, right? Correct? What else? So you can separate substances into. I kind of already did this. Element, compound, yes? And what would you do? What kind of mixtures do you have? You have one phase, or you have, that's not very readable, is it? One phase, or multiple phase, right? What's a one phase? What's that mean? A one phase? Yes.
One step.
Well, one set of physical boundaries. Boundaries. When you think of a phase, what's the word you think of? A phase, like a phase of, I don't know, my child's going through a phase, like a period of time you think of, right? Well, a phase can also be a set of physical boundaries. For instance, if I have water and salt together, is that a substance? It is? It's two substances, isn't it? But do you see the salts? No, you just see the water, right? So that's a single set of boundaries, so that's one phase. Okay, so this would be a solution. Correct? That would be a solution. Sugar and water, how many phases do you see? You see two phases when you put the sugar and you stir it? You see one phase, right? This is actually called a mixture. You have two types of mixtures. You have solutions and you have something called a mixture. That word has two meanings. The word set, S-E-T, has over 150 definitions. So do you understand that a word can have more than one definition? Yes? Okay. When you're learning another language, how you say a word can make it have a different meaning. Is that true?
Yes.
Yeah. Just your tone. Nah. 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 Okay, it has a meaning. Okay? All right? So that's it. You have matter, substances, elements, compounds. You can separate a mixture, which is heterogeneous. This is homogeneous. You can have heterogeneous into more than one. You can have different types of mixtures. You can have a phase called a solution, correct? A solution. This is also, you can use the word homogeneous, can't you? Can't homogeneous have more than one word? Homogeneous can mean you can apply that to a substance, a pure material, or it's completely stirred. Listen carefully. The salt is homogeneously distributed within the water, thereby causing the formation of a solution. Is that okay too? That was cool, huh? Just came up with that. Wow, weird, huh? So this can be homogeneous, but you can also have a homogeneous combination. You can have homogeneous in terms of pure. This is going to be hetero. Hetero. It can be heterogeneous. Okay? Clear? Are we all right with that? So is there anything, so you have to, according to chapter 2, which chapter 2? I have it right here somewhere. Pardon me while I am confused. Chemical reactions. You have to know the difference between, we did this, right? The difference between physical and chemical reactions. What's the main difference between a physical and a chemical reaction? What's the main difference? Chemical reaction is the formation of a new substance, right? Hydrogen, pure substance. Oxygen, pure substance. Whoa! Formation of water. Chemical reaction, forming a new substance. Correct? Yes? Right? That's a physical one, though, is what? You're just taking ice and you're changing, you're freezing it. Yes? If I thaw the ice, do I still have the water? Do I? Yeah, of course. Granted, I'm taking water and I'm freezing it, okay? If I melt it, do I still have water? Yeah. Now, this is interesting. Solid water has different properties than liquid water. So it's almost like different substances. Frozen water has different properties, different physical properties than liquid water. Amazing, huh? And gaseous water has different properties as well. But if I change from a liquid to a solid, I'm not making a new substance. I'm just using physical changes for physical properties, physical reactions. Chemical changes, chemical properties, chemical reactions. What's a sign? What are two major signs of a chemical reaction? Let's say three major signs that I'm thinking of. What are three major signs of a chemical reaction? And you don't necessarily just use one. Yes?
Fizzing.
Fizzing, formation of a gas. I like that. Like it. What else? Yes?
Viscosity.
It's what?
Viscosity.
Viscosity is the ability or the inability to flow, like water versus honey. Maybe you change the viscosity. That could be physical or it could be chemical. That's why if you have fizzing, or you may want to have more than one sign to say that it's a chemical reaction. Yes?
A change in color.
I like that, change in color. Change in color. But maybe the liquid form is clear and the solid form is white. Another, you want to use more than one. Gives off heat. Color change, heat change, fizzing. What else? Yes?
Maybe it smokes.
Smoke, maybe giving off. Like burning wood? Maybe. What else?
Change in shape.
Change in shape, could be. Change in shape, sure. Could be. Could be. I take the water and I put salt in it. I run an electric current through the water and I form hydrogen and oxygen. I'm changing how it's shaped, yeah? From a liquid to a gas. Could be evaporation, but it could be a chemical change. So you want to take more than one. What else? Chemical change, yeah.
Maybe a change in size.
Change in size, shape, yeah. What about all of a sudden you're looking at this clear liquid and all of a sudden you get this formation of this orange yellow solid. What's that called? Formation of a what? When you get like a solid all of a sudden appears, the blink of an eye. when you mix silver nitrate with something, you get the formation of a solid. What is that something? Lead nitrate with something, you get a formation of a solid. Yeah? Everything all right there, Professor?
The electrical, of course, cut out in the Hogar, so we're gonna boil water and mix and match until we get a bunch of six.
I like that. I like that. I like that. Excellent.
I may come steal your electrical source.
That's my boss. He's stealing all my equipment. He's going to steal my students next and the tables. Then I have no one left, but I'll still record the video, okay? Who needs an audience? Okay. So, you get it? Yes? Okay. So that's going to be chapter 2. Did we do a good job?
Yes.
All right, so the next one I'll make tomorrow is 4, the next one is 5, etc. Clear? I'll do one a day because you guys are starting to fade. Yeah? Excellent. But I like when you pay attention. Alyssa, you look like you're right there. Right there. Great smile. Yeah, doesn't she look like, does she? I mean, you guys can see her. Look at her. Look at her. Turn around. She's right there. See that? Look at that. She's right there. I like that. Marin too, right there. I like that, Laura. That Finnish glare, I like it. Intelligence. We're off.